Hello everyone, welcome back to the Python programming series. In the previous lectures, we have learned about variables, data types, and operators. So, in today's lecture, we'll start with control flow statements, the building blocks that help a program make decisions and repeat tasks. So, we'll begin with the conditional statements like if else, if elif else, followed by looping statements such as for loop and while loop. We'll even discuss the break, continue, and pass statements. So, let's get started. So, starting with the control flow statements, we have three types of control flow statements. First, we have the selection statements, iterative statements, and finally the loop control statements. So, in selection statements, we have if else, if elif else, followed by nested if elif else, right? So, selection statements help us understand which of the multiple paths should be taken, right? They help us decide which path needs to be taken based on a particular condition. Next, we have the iterative statements, which include the while loop and the for loop. They execute a set of statements repeatedly based on a condition, right? You can iterate. Next, we have the loop control statements, which include three main statements, which is break, continue, and pass. So, they transfer the control of flow to some other section based on a condition. This is a basic overview of what we will be discussing in this lecture. So, let's start real quick. Let's start with the if statement first. So, this is the syntax for if. You write if test expression and the statement you want to perform if the condition becomes true. Always remember to place colon. Here's a point to note that the non-zero values are considered true in Python, whereas the 0 or none is considered a false value. Next, moving on to if else, we have the syntax as follows. If expression, you write the body of if, else the body of else. So, if the condition in the if block is true, the statement would be executed. Otherwise, the else part would be executed. Next, so this is to be used when multiple mutually exclusive expressions are there. So what if there are more than one testing conditions that you have, right? So in that case, you can include the rest of the conditions in the elif blocks. You can have as many elif blocks as you want. Starting with the if block, you have if, the expression you want to check, body of if, then elif, this expression, body of elif. Also here note down one thing, that there's indentation being followed. In if, the body of if is written with an indentation. Same in elif and then else as well, right? Also, I want to tell you a very important code that comes in handy. So if you want to check for a leap year, whether a given year is a leap year or not, there's a condition you need to know, that the year should be divisible by 4 and it should not be divisible by 100. Either this condition should be true or the year should be divisible by 400 entirely, right? So that ways you can check a leap year. We'll be discussing it in the programming questions as well. Next we have the match case statements, right? So it is a better substitute of the if-else statements. I find it a better substitute. So we write match keyword, variable name, colon, with an indentation, you add the case, you write pattern 1. The code block comes again with an indentation, you write next case, the pattern you want to match with, then another indentation, and the code block, and so on, the cases go on. But there's a default case that you can mention which is depicted by an underscore. Here we are writing case underscore, so it is a default case like else, which is executed if none of the conditions, or we can say that none of the case match. So I want you all to try these programs. Take user input for day from the user, right? Ask for a weekday. I want you to check whether it's a weekday, a weekend, or not a valid day. Try to do this code using the match case statements, right? Next we have the looping statements, the while loop, right? It is an iterative statement. So the syntax goes like this. We have while condition, code that needs to be executed repeatedly. Next we have the for loop. So the syntax goes like for value in sequence, and then you write the body for. In for loop, we use a function which is the range function. So there are three ways to use the range function. Firstly, we have range, and then in brackets you can specify the stop, the point at which you want to stop the value. Then we have range. You mention both the start and the stop values. And lastly, we have a range function which takes three arguments: start, stop, and step. Here are a few examples I have mentioned. Supposing I say range of 6. So it will iterate from 0 to 5. If we write range 1, comma 6, that means the start is 1 and the stop is 6. Here we are not including 6, right? So it will go from 1 to 5. Next we have range 2, comma 8, comma 2. We are specifying the start, stop, and step. So in this case, we will have the values starting from 2, incrementing by 2 each case, and then ending at 7. 7 won't be included because we are jumping by 2 steps, right? Let's have a look at this example on the right side, which says items is equal to Python. We are assigning a string to it. So for item, in items, we want to print the item, right? So firstly, it will start with P, then it would print Y, T, H, O, N, right? So it will go on printing the alphabets that are there in the string Python. That is how a for loop works. Next we have the for loop with else clause. This is the syntax for a for loop with else clause. We write for I in sequence, write the loop body. If condition, you can break it or write the body. Else, you need to write the code that needs to be executed when the loop completes without encountering a break, right? This is how it goes. Coming to the nested for loop. So a nested for loop is simply a for loop inside a for loop, right? So the outer loop runs first, and for each iteration of the outer loop, the inner loop runs completely. So we start with the outer loop, and for each iteration of the outer loop, the inner loop runs completely each time, right? Next we have the break, continue, and pass statements, the loop control statements. So what does break statement do? It exits the loop immediately, right? Continue statement is used to skip the current iteration and move to the next one. Moving forward to the past statement, it does nothing, it just acts as a placeholder so that you don't get an error, right? Now let's do some coding practice and understand the control flow statements in detail. Here's a point I want you all to note here, that a for loop iterates over an exact sequence or iterable collection. In a for loop, the number of iterations is known beforehand, whereas in a while loop, it runs until a condition evaluates to false. So the iteration count is unknown as it depends on some condition. You'll use a for loop when looping through a list or counting exactly up to 100. Whereas you can use the while loop when you are waiting for a valid user input. In today's lecture, we are going to learn about conditional statements, that is if, elif and else. So let's begin with a very simple if code. So for example, if you want to check whether a person is eligible to vote or not, you can do it using a simple if statement, right? For example, let's suppose the age is 20 and we put a condition that whether the age is greater than or equal to 18, if it is, then the person is eligible to vote, right? Let's make it print that and see if it works. Otherwise, it will print nothing. So yes, since 20 is greater than 18, the output is eligible to vote, right? We can even add an else statement along with this to print that the person is not eligible in case the if statement is not true. But in this case, it was eligible. Let's try to change the age and check for some other case. Supposing let's check for 15. So it prints not eligible, right? So that is how a simple if-else statement works, right? So next code, let's try to do to check whether a number is positive or negative. So in that case, two cases can arise. If the number is greater than or equal to 0, then of course it is positive. Otherwise, it would be negative. Let's consider the case of equal to 0 as positive only as of now, right? So let's write the code first, right? Let's take an input from the user itself, right? Always remember that input gives a string function. So we need to typecast it to int, right? We discussed it last time and you must remember it always, okay? So let's check if the number is greater than or equal to 0, it should print positive, right? Else it should print negative, right? Let's comment this out and try to run. Let's add a number supposing 12. So yes, it is positive. Now let's try to run it again and check for some negative number, -1, let's suppose. So yes, it shows negative. So this was the code to check whether a number is positive or negative, right? Similarly, you can perform for whether a function is even or odd. In that case, you will check the condition whether the number is divisible by 2 or not. And that you can do using the modulo operator. That was the percent sign, right? Similarly, there could be other programs like you can check to compare two numbers, right? And now let's move on to the next statements, which is if, elif, else statements, right? Supposing there are more than two possible conditions. you need to check for, right? So let's take a variable marks and ask for the input from the user, right? Let's typecast it to int. And now let's prepare a grading system. For example, if the marks are greater than equal to 90, then the person scores a grade that is A, right? Now let's try for elif because we have a number of conditions here. So we would be using elif statement here, right? So if the marks are greater than equal to 80, then it should print B, right? Similarly, supposing you have another condition, which is if the marks are greater than equal to 70, then it should print C, and so on. It can go on, right? And then the else statement, which is a compulsory statement here. Otherwise, the student is fail, right? So let's try to run this now. It asks for the marks. Supposing the marks are 85. So in that condition, the marks are greater than equal to 80, so it will print a B, which is clearly the output here, right? Similarly, you can check for others as well. Now there's a very common program that you must know to check the largest of three numbers, right? Supposing you have inputs for three numbers, let's try to have the inputs already. And then you need to check which number is the greatest of all, right? So in that condition, you need to frame the logic for it. So you'll start with A, right? In this case, it is 10, right? So we'll check with B and C. So 10 is not greater than B, right? And not greater than C as well. So we'll move to the next one, which is B. B is 30, which is greater than A but less than C, right? And then we have C, which is greater than A and greater than B both. Therefore, it will be the greatest of all, right? So let's try to put that condition first. So if A is greater than equal to C, both B and C, then only it will print A is greatest, right? Then we'll create an elif statement which says if B is greater than both A and C, only then B is the largest, right? Otherwise, let's put the else statement since we only have three numbers, so three conditions would be there. Else print C is the largest, right? You can write the conditions in any order. Now let's try to run it. So 40 is the largest, and that's what we concluded from the above cases, right? That C is greater than B and A both. Therefore, C is the largest, right? So, there's one more code that you all must know, the logic for, okay? So, you need to know the logic for a leap year, okay? This is a simplified version that I would be teaching you. And there are many other ways to find whether a number is a leap year or not. So, supposing, let's take input for year, right? And now let's use the if condition. So search out the logic for this, and you must know that for a leap year, there's a combination of conditions that needs to be checked, right? So I'll be teaching you that. So you all know that for a leap year, it should be divisible by 4, right? So let's mention that first. That year should be divisible by 4. That means when you use the modulo function, the remainder should be 0, right? And side by side, it should not be a centurial year. That is, it should not be divisible by 100, right? This is the not symbol, right? Either this condition should be true, let's put it in braces, or the year should be divisible by 400, right? Always remember this. This is a very simple logic. Try to use as many relations as possible. Otherwise, it should print that it's not a leap year. Let's try to run this. So yes, it is a leap year, right? Similarly, let's check for 2024. So yes, it is divisible by 4. So yes, again, it is a leap year. Let's check for some centurial year now. Supposing let's take 1900. Right. So yes, it is not a leap year. And similarly, you can check for other years as well. Supposing we check for 2000, it will be a leap year, and so on, right? So you can practice a number of programs related to the conditional statements, right? I would suggest you to perform these programs by yourself. Again, that is positive, negative, or zero number, and the largest of three numbers as well, to check if a student has passed, right? And this leap year one is actually very important. And there could be many more programs like calculating the ticket price based on the age, wherein firstly using the if statement, you would be checking the age and then performing a variety of operations on the ticket price, fixing a ticket price according to that, right? Then check if a number is divisible by both 3 and 5, right? Now, in case you feel like doing one more problem on the same, let's try for a vowel and a constant, okay? So let's take input for a letter. Supposing let's take A, and if letter, obviously, so now we would be considering both uppercase and lowercase letters, right? So let's try to convert all the letters that we get into lowercase. So there's a function for that which is lower, right? So here this capital A would be converted to a small a, and then let's check whether it is in the vowels set, the set of vowels which is A, E, I, O, U. In double quotations it should be, right? With a semicolon. Then it should print that it is a vowel. Else it will be a constant, right? Let's try to run it and it should return a vowel. So yes, it returns a vowel. Supposing we take a small b already. So it's a constant. What if we take a u? Then it should be a vowel? Yes. Right? So this lower function is to change the alphabet or the letter to lowercase. Alright? Let's start with a practice on some while loop programs. Here's the code written on the screen to print numbers from 1 to 5 using a while loop. We are initializing I with a value of 1. Starting with the while loop, we are iterating for each value of I ranging from 1 to 5 and printing the values for I and then incrementing it by 1 for each iteration. Let's try to run this code and see if it works. We should get I from 1 to 5. Yes, it perfectly matches. Now let's try to print even numbers from 2 to 10. So this time we should initialize it with 2 because we want the numbers from 2 to 10, right? All the even numbers. Let's start with the while loop. While I is less than equal to 10, because we want it to till 10, we need to print I and we must increment it by 2 this time. Let's comment the previous code and run this one. So yes, we get all the even numbers from 2 to 10 in this case. Similarly, you can try solving it for printing odd numbers from 1 to 9. In that case, you will initialize I with 1, iterate I from 1 to 9, and then again increment it by 2 each time. Now let's try another code to write the multiplication table of a number. Right? Let's take an input from the user itself. Let's use the input function. Ask the user to enter a number. Typecast it to int. Next, we need to initialize I with 1. And then for the table to go from I is equal to 1 to 10, we need to place I as less than equal to 10. Let's print the number. Let's add some formatting to it. Into I is equal to num into I. So num remains fixed. I increments from 1 to 10 each time. We need to increment it by 1 each time. So plus equal to 1. Let's try to run this code. So it asks for entering a number. Let's take 10 and here is the code. Let me clear the terminal and run it again for you. So by entering a number, let's say 9 this time, you get the entire table from 9 till 90, right? Next, let's perform another code using the while loop. Let's try to perform reverse counting this time. So this time we'll initialize I with 10 because from 10 till 1 we need to go. So while I is less than, this time we'll say greater than equal to 1 because we want it to go till 1. So while I is greater than equal to 1, we need to print I and then each time decrement it by 1 because we want to have the reverse counting. Let's try to run the code and hopefully it works. So yes, from 10 to 1 reverse counting is done. Right? Let's comment this out. Move to our next code. So now for example, let's try something different. We want to find the factorial of a number. So we'll take the input from the user, typecast it to int, and then let us initialize the factorial with 1 this time, right? So while let's take the number. If the number is greater than 0, because we always know that factorial is found for a non-negative number. So while num is greater than 0, we want the factorial to be multiplied with the number each time, right? Let's take the number minus equal to 1. We'll decrement it. Let's try to print the factorial, which would come out to be, let's take a number, supposing let's take 3. So it should be 6. So yes, the factorial is 6. So what do we do in a factorial? We say 3 into 2 into 1, right? We keep decrementing the number by 1 each time, and then we keep on multiplying it. That is why we are using this code here. Hope that is understood. Now, let's try to count the digits in a number. This would be our last code, and then I'll be asking you to write a few programs. For example, let's take the number as 10 this time, and we want to count the digits in a number, right? So we already know that there are 2 digits. Let's suppose the count to be 0 for initialization. So while num is greater than 0, let's take this condition for a positive number. We are considering it, right? Num floor division is equal to 10, and adding 1 to the count. The count would be computed each time through iterative steps, and the digits would be counted. Let's try to run this code. It should give us 2, and yes, the digits come out to be 2. So each time we are extracting the last digit and then moving on to the next. Let's take 100 for example now. So 3. Let's take 1000, 4. So each time, starting from the last, the right side, we are moving to the left and counting the digits, the total number of digits in a number. Now, I would want you to practice a few programs related to the while loop, okay? So, last topic I would like to discuss is the break, continue and pass statements we discussed. So, I'll use one simple program for that. I'll write a program and explain you how it works using the for loop. So, let's take a for loop for I in range of 1 to 11. So, I will go from 1 to 10. If I is equal to 3, we want it to pass. I explained you that pass does nothing. It acts just as a placeholder. And if I is equal to 5, I want the program to continue, which means skip this iteration and move to the next one. Else, let's add another condition in elif only. Let's see. Elif I is equal to 8, I want it to break, right? Else print I, right? Let's try to run this code now and see. So let's try to understand this one by one, each line. So I is equal to 3. When we had I is equal to 1, it printed 1. When we had moving to I is equal to 2, it printed 2. Moving on to I is equal to 3, which matches our if condition, it passes, right? There's a pass. So it does nothing, right? Next we have I is equal to 4. So it gets printed I is equal to 5, there's a continue. So it skips this iteration and moves on to the next one, which is I is equal to 6. So I is equal to 6 gets printed. I is equal to 7 happens the same way. For I is equal to 8, there's a break statement. So after that, it exits the loop and nothing happens. So I is equal to 8, 9, 10 don't get printed at all. So in conclusion, I can say that the break terminates the loop immediately. The continue statement skips the current iteration and moves to the next one. Lastly, the pass statement acts as a placeholder. It does nothing. Right? So let's write our very first for loop. For example, we want to write welcome to Python 5 times. So how would that happen, right? So for that, we use a for loop. We declare a variable I in range. There's a range function. How many times you want to run the loop, right? So for I in range of 5, it needs to print welcome, right? Let's try to run it. So there's welcome 5 times, right? So the loop runs 5 times, that is 0 to 4. Okay. So for our value of I to be 0, then for value of I to be 1, 2, 3, till 4, right? Now what if we want to print the numbers in range from 1 to 10 all? So you just need to make a minor change. Instead of 5, you need to write the start value and the end value increased by 1. So this will make the loop run from 1 to 10. Here you want to print I, that is 1 to 10. So let's try to print it. See, yes, numbers from 1 to 10 get printed, right? The start and the stop point increased by 1, here 11, right? So the arguments in the range go in this order that you need to mention the start, the right for you start, the stop, and then the steps. Okay, the increment that you want to make. Now, for example, we want to print even numbers, right? So for that, we will be using 3 arguments because we'll have to skip one number in between for all. So for I in range, let's start from 2 itself, even numbers, then 21 till 21, let's do it, yes, right? And then increase by 1 each. Let's see. We want to print I. So when we will run this program, we'll start from 2 and go till 20, right? So 2 is the starting point. So it starts from 2. Then till 20, it goes up till 20 and increments by 1 each. So after 2, there's 4, then there's 6, 2 plus 2, and then 4 plus 2, 6 plus 2, and so on, right? So the range function can take up to 3 arguments, the start, stop, and step. Okay. Similarly, you can print odd numbers. So for that, you will be starting with 1, then go till 20, and increment by 2 again. Right, so here again, there's 1 till 19, all the odd numbers. So try to practice a lot of examples related to the for and while loops, right? Now, for example, you want to print the numbers in the reverse order, sort of countdown. So, how will you do that? Try it on your own first and then come back to this program in case you face any trouble, right? So, let's try for I in range of, we want to start with 10 this time, okay? Go till 0 and then keep decreasing by 1. So, we'll write -1 because that's a step, okay? And then we want it to print I. Let's try to run it. So yes, starting from 10 to 1, right? 0, which is less than 1, right? In case it would have been 1 here, let's try that as well. So it would give 10 to 2, right? What if we write -1 over here? So it will even include 0 this time, right? So you can do it that way. Just try all the possible combinations and you'll get the desired output, right? Similarly, you can perform multiplication using for loops, right? Let's take an input, for example. 1 second. For example, let's take a number 5 and then try to print a table. For I in range, let's print the table from number into 1 till number multiplied by 10, supposing, right? So we'll write starting from 1 till 11. It'll take you to 10. We want to print the number into I, right? That is what we want to print. Let's write few things as well so that it becomes clear, right? 1 second, just move it. So num multiplied by I is equal to num into I. So, right, it should be printing something like 5 into 1 is equal to 5 into 1 is equal to 5 and so on, right? Everything in the next line, right? And so on. So let's try to run it and see what it prints. So yes, from 5 into 1 to 50, right? So num remains constant, then 1 to 10 multiplied by 1 to 10 and the output over here, right? So you can perform multiplication like that. Similarly, for finding the sum of first 10 numbers, in case you want to do that, right? So for that, the code would look something like, let's try it here. So for I in range of 1 to 11 will take, so that it goes till 10. And then sum may will keep, let's take the variable sum only. Sum may will keep on adding the value of I, right? But then you all should observe one thing, that in this case, it will give us an error, which would be built-in function method and it, right? Sum plus equal to I. We haven't defined sum. So we need to initialize it with 0, right? Now let's try to run it. So every time it will give us numbers like this. But that's not what we want, right? So every time the sum starts from 1, then 2, then 3, and then it gets added, so on, right? So every time it gives you a new sum, but we want a final sum. So we'll take it out of the loop, the for loop, and try to run it again. So the answer would be 55. And that's the correct answer, right? So you always need to initialize the variables that you would be using inside the for loops. And then you can increment it or decrement it as per your need. Similarly for factorial, try it for factorial once, and in the very next lecture we'll be doing for factorial as well. Then I want you all to try it for print every character of a string. Let's do it now only. For example, we have a string which is, let's take Python, and we want that every character is listed separately. So how would you do that? Let's take a variable, let's say letter instead of I this time, right? So for letter in name, we wanted to print in the letter, right? So firstly, it will print P, then Y, then THON. That ways, right? So strings are iterable. This is what we get through this code. That strings can be iterated. Firstly, we are getting pi, then moving on to y, right? Then t, and so on. Similarly, in case you want to find the number of letters in a string, so for that case also, you can use a for loop, right? Supposing we have this, and let's say for letter in name, we want it to show us the number of letters that are there in this word. For that case, we'll have to define a variable now. Let's take count. But outside loop also we need to define it. Let's initialize it with 0 letters, right? Then it would start iterating, and then it should be equated with 1. Increase by 1 every time it counts a letter, iterates through, right? We'll get out of this loop and we'll ask it to print us the count. Let's see if this code works. So yes, there are 6 characters in a string. Let's try to check whether a space is counted or not. So 18 characters it says. So 6 and then 7, 8, 9, 10. Yes, right? So 18 is the right answer, including the space as well. Similarly, you can perform for the rest.